everyone, and welcome to this video in which we will understand what data engineering is. The world in general has been continuously evolving around the data. Organizations have realized how valuable an asset data can be and how it can manipulate key business decisions, or at least that was the expectation. But back in 2017, Gartner's report stated that 85% of big data projects failed. One of the most important factors leading to this was the available data infrastructure was not reliable enough to make business decisions. According to the CTO of IBM in 2019, 87% of data science projects could never make it into production. Why is that? If data is so valuable and most decisions can be made using the data available, then why were so many data projects failing? Well, we are moving towards a world where we will be producing 435 exabytes of data per day. To put that in perspective, that's 1 followed by 18 bytes worth of data. This is where data engineers come into picture. Earlier, data scientists were expected to structure, source, and build pipelines for data. These tasks were often out of data scientists' scope of work or their skill set. The result was that data modeling would not be done correctly. There would be a redundant work and inconsistency in the use of data among data scientists. These kind of issues prevented companies from being able to extract optimal value from their data projects, so they failed. Eventually, more and more organizations began to realize the need of professionals who can transform and transport data in such a way that by the time it reaches an end user like data scientists, they are in highly usable format. Data pipelines are created by data engineers and they are used to build a warehouse of data collected from different sources and used across the entire organization. Data engineering came to be described a kind of software engineering that focused deeply on data infrastructure, data warehousing, data mining, data modeling, data crunching, and metadata management. Data engineers work in a variety of settings to build systems that collect, manage, and convert raw data into usable information for data scientists and business analysts to interpret. Their ultimate goal is to make data accessible so that organizations can use it to evaluate and optimize their performance. While data scientists are highly skilled in maths and statistics, R algorithms, and machine learning techniques, data engineers are more versed in SQL, MySQL, and NoSQL architecture and cloud technologies and frameworks such as Agile and Scrum. LinkedIn's 2020 Emerging Jobs Report and Hired's 2019 State of Software Engineers Report rank data engineer jobs right up there with the data scientist and machine learning engineer. Although there is no such exhaustive list of skills required for becoming a data engineer, but there are a few that have remained in demand ever since. Some of them are knowledge of programming languages like SQL, Python, R, hands on expertise in relational and no relational database, knowledge of ETL systems, knowledge of data warehousing. Tools such as Apache, Kafka, Spark, and Hadoop add a lot of weightage to your skill set. And last but not the least, cloud computing technologies such as Azure, AWS, or GCP. So that's all for this video. Hope you have understood what is data engineer and how it is different from data scientist, and also what skills are required to be a data engineer.
Hello everyone and welcome to today's session on Data Engineering Full Course by Intellipaat. You know, it's pretty difficult to do any data science without the data engineers being there to support this function. Now, there is a frequent collaboration between data engineers and data scientists. However, the priority skills and the knowledge of tools vary. I'm sure you all might be having a lot of questions regarding data engineering. So, without any further wait, let's directly ask the expert. So, joining here with us today is Suyash, who is an expert on data engineering. Hi, Suyash.
Hi, Dev.
So, tell us, Suyash, what exactly is data engineering?
Okay, so basically, data engineering helps make data more useful and accessible for consumers of data. It's now widely recognized that companies need both data scientists and data engineers in an advanced analytics. To learn data engineering is basically, it is difficult to define precisely. Okay, so it is basically about the designing and building the data infrastructure needed to collect, clean, and format data, making it accessible and useful for the end users.
Okay, that was a precise explanation. Now, tell us, Suyash, what exactly is the difference between a data scientist and a data engineer?
Okay, So basically, data engineers are the ones that prepare the data from raw data, which is basically unformatted, and it may include like human errors or the machine errors. Okay. So a data scientist works on the data which is provided by the data engineer. A data scientist is dependent on a data engineer basically. A data scientist analyzes the data and gives insight as to how the company should work based on that particular data analysis.
Okay, that was a good answer. So, Suyash, could you please throw some light on the various career prospects and job prospects regarding this data engineering?
Okay, sure. So basically, after a huge influx of data scientists, companies realize that they need proper data infrastructure to perform any meaningful analysis on data. Companies have even started to spend money on proper cloud infrastructure, data architecture, and even hiring new data engineer talents. One solid proof of demand for data engineers is the growth in big data. If you have been living under a rock, data is the new oil. So basically, new data is being generated every day and it will continue to grow as well. With the insane amount of data, there will be an increase in the demand for engineers to handle the data. Another giveaway is the growth of big data engineering services provided by consulting firms like Accenture and other tech companies like Cognizant. With the increase in data, proper data engineering services is also increasing.
Okay, that seems like data engineering is in good demands right now.
Absolutely.
Well, thank you so much, Suyash, for answering all those questions of mine in a great detail.
You're welcome, Dave. So basically, this is just the tip of the iceberg. We'll be learning the complete data engineering process in this whole course.
That's great. So, without any more wait, let us get to our today's agenda. So, before we move on to our session, please make sure that you are subscribing to our YouTube channel.
And hit the bell icon for more updates from IntelliPad. Now let's start the session.
What is really big data means for us and what is Hadoop and relation between these two actually. So it's not something data is exist now. So it is there from beginning, almost 20, 30 years onwards, the data is there. But all of a sudden, people and a lot of organizations started discussing, a lot of discussions are going on the big data. So what is the meaning of big data means for us? So before I take you in depth about the big data, first of all, you have to understand a little bit about the data. So what is data? So probably you can think on that. What is data all about? Data is nothing but collection of some information, right? Anything. If you are keeping some information together, then you can call that one as a data, right? Data or data set actually. So, when you are going to see the data, how you are going to see the data or data sets? Basically, from different data sources, you're going to see the data set. Just forget about the big data definition. So I'm just going through about the data set actually. So now data sets will be generated or data will be created out of the data sources basically. So you can just take the simple example, this Zoom. Zoom is one of the data source where we are seeing a lot of data will be generated behind the screens. So how we are discussing the audio, the video, the statistics, and the network, and who joined at what time, who left what time, all these things will be captured behind the screens actually. So that is all about the data set actually. Data sources are the one who is going to generate the data. Without data source, there is no data actually in this world. Very clear statement. Without data sources, there is no data. Everything, your cell phone is a data source, your personal computer is a data source, your YouTube is a data source, social data is a data source, right? Social networks, probably Facebook or Twitter or anything, right? And also a transport data, right? YouTube data, satellite data, right? And also stock exchange data. All these are going to be the data sources actually, right? So data sources are the one who is going to generate the data actually. So Ajay says, what is data set example, right? So for example, right? So you went to the market and to vegetable market or probably to grocery and you got some items, right? and he's going to print a bill for you with a list of items and their amount, right? That is a data indirectly, right? So the data you are going to maintain in a simple in a computer world in terms of data set actually. If you are maintaining, earlier we used to maintain the data in the documents, nowadays we are maintaining the data using computers as a in terms of data sets actually. Collection of some data if you are maintaining in your computers, that is all about your data sets actually. Legacy systems, right? Or traditional techniques. So using these things, we can really maintain the data actually. So these notes will be shared as a class notes, friends. You don't have to write down or you don't have to be busy taking the notes throughout our discussion. All you have to concentrate on my screen because everything will be shared with you. Okay, whatever I am showing on my screen, except paints, where we are going to use here and there paints also, except that we are going to share everything with you actually. So now let's go ahead and see definitely legacy systems, right? So one of the widely used in terms of data, it's mainframes, .NET, right? Or Java, it's one of the widely used RDB, DBs, right? Or any ETL tools, right? etc. So using this, you can maintain the data actually. So these are really well matured systems, friends, from beginning, and you don't have to worry about to maintain the data. But how far they can maintain the data? Maximum terabytes of data they can maintain, because when they designed the systems, they thought they are going to see maximum terabytes of data. That's how these tools were designed, and there is no question at all. When you are seeing the terabytes of data from your data sources, these systems are excellent systems actually. But now definitely you see, are you seeing only the maximum terabytes of data? No, we are going to see petabytes of data, which means 1024 terabytes equal to 1 petabytes, exabytes of data, zettabytes of data, yottabytes of data, etc. You started seeing this much of data from our data sources. But when you see this much of data from your data sources, but when you are trying to manage this much of data using these existing systems or traditional techniques where they are not able to tolerate your data, then they can start calling the data set is a big data. So what is that? Big data, it is a data set only, right? But this data set, we are not able to manage using the existing techniques actually, because it's a huge volume of data. It is beyond their storage capacity, beyond their processing capacity. So that is the reason they are not able to really tolerate the data actually. Clear? Big data, probably you might have thought you are going to learn as a language, as a technology, as something else, but you are not going to do anything with that. Simply big data is nothing but it's a data set only. It's a collection of some meaningful information, but using your existing systems, you are not able to really manage it actually. Clear? So that is all about the big data. When your existing systems are overloaded, simply you can call your data as a big data. That is as simple as that actually. So using your existing systems, we are not able to tolerate your data. Definitely we have to think the alternatives. We have to introduce the alternative for the big data actually. So now how we are going to do it? Let's go ahead and see one by one actually. So as you can understand here, right, there are many systems were born to handle your big data. So it's not a single uh, system or framework that was born to handle your big data. There were many systems were born in this market to really just address your big data related issues. So one of them is going to be the Hadoop, right? And also you see Spark, and also you can see HBase, MongoDB, right? etc. These are the frameworks which were born to really understand, to address your big data related issues actually. So what are the big data related issues? Basically, storage one, big data issues. There are two issues basically, right? Storage related issue, processing related issue. So these are the two issues that you have to understand, that you have to address whatever you're going to introduce actually. So what is big data? I mean, what is Hadoop basically? Hadoop is only it was born to address your big data related issues. Hadoop is going to address your storage related issues out of your big data. Hadoop is going to address the processing related issues out of your big data. Hadoop can manage both the things. So now let's go ahead and see how we are going to really, right, process, how we are going to store the data, how we are going to process the data using Hadoop. What is the specialty with the Hadoop than you're comparing your legacy systems actually, right? Before that, let me introduce about the big data definition from IBM side using 5Vs actually. So very, very important thing. I don't want to miss that one because most of the interviewer is going to ask those questions. So what is big data definition using 5Vs actually? Let me pull that documentation. So I'm going to share this one with you. So very simple, 5Vs means volume, velocity, variety, veracity, and value. That's how nicely they are calling as a 5Vs and 4Vs and 3Vs and all. So you don't have to worry. So all you have to understand about what is each V means. Then how we are going to leverage this each V definition to define your big data. We are going to see one by one actually. So let's see. So what is volume of data? Volume of data is nothing but simply the amount of data that you add from your data source to warehouse actually. So if you take any example, right, you are going to add some amount of data actually. So you're going to add some amount of data and you're going to see some amount of data and you're going to see that will be retained somewhere else actually. You're going to you see some amount of data from your data source, probably you can think of Amazon, and you are retaining somewhere else in the warehouse actually. So now you are trying to really just dump the data from here to here. So whatever the volume, whatever the amount it is, but you are going to retain the data. So let's understand volume means. So volume is nothing but velocity, right? I mean, volume is nothing but amount of data that you are adding from your data source to warehouse. From this data source into your warehouse. Warehouse is nothing but it's a place. It's a common place where you're going to retain the data, that is called warehouse actually. Amount of data that you are adding from your data source to warehouse is called nothing but volume, right? That is the volume definition. The amount of data that you added from your data source to warehouse. It can be anything in size. It can be bytes, it can be MBs, it can be GBs, it can be petabytes also. So that is called volume. Velocity is nothing but at what frequency you're trying to add the data from your data source to warehouse. So for example, you are seeing around 4 terabytes of data here. This 4 terabytes of data is being added at what frequency? How long your data source has taken to add this 4 terabytes of data? Is it taken a month, a week, and a year, in a month? So that's what your velocity means. At what frequency you're trying to add the data. It can be a day, it can be a month, it can be a year, it can be 10 years actually. So that is all about the frequency of adding your data actually. That is velocity. You know volume, you know velocity. The third thing is variety of data, right? So order does not matter, friends. All you have to understand each V means. So variety means, as the name says, variety, different forms of the data actually. So in this data world, right, if you take any data, that has to be categorized into one of these three ways: structured data, unstructured data, and semi-structured data. As the name says, structured, your data is been well organized in your data set. That's how we will be calling as a structured one. Unstructured, there is no structure at all, right? Your paint is unstructured data, your image is unstructured data, your audio file, video file, everything is unstructured. There is no structure, right? Binary format completely, right? That is unstructured. We know very well about the structured and unstructured. So what about this semi-structured? So half of the data, as the name says semi, half of the data, your data has been just structured and rest of the data is not been structured actually. So you have to really process that unstructured data to make it as a structured one actually, right? To make it as a structured one. That is about the semi-structured actually. Your XMLs, JSONs, where we are going to use in our application. So where data exchange can be happen more frequently using your XMLs. And we are going to see more about the XMLs. You don't have to worry about that in our big data world, Hadoop world. So XML is all about the parent and child tags. We are going to see down the line how they are going to be working actually. Okay, that is all about the right structured, unstructured, and semi-structured. So we are going to see down the line how we are going to just leverage these definitions to define the big data. So we know structure, we know volume, we know velocity, we know variety. The next thing is veracity. So veracity is nothing but the accuracy of the data, right? So always there will be inconsistency, which means there is no accurate data you can see out of your whole data actually. If you collect, for example, right, 1 terabyte of data, 1 terabyte of data is not going to be the accurate data. You may see, right, some of the data is really, for example, if you're taking Amazon example only, or probably if you take any data, I mean, a exit polls are conducted in so and so city regarding the elections that has happened recently. So do you think all are going to be the accurate one? All the data that you see is the accurate one? No, some of them they just like that they submitted. Some of them they gave, they don't know anything what's going on. Some of them are not eligible, but they gave. But you see all data, but you have to separate it actually. That is called inconsistency. That is what accuracy of your data. Finding the accuracy is very, very important out of your data actually. So history says only the 70% of whole data will be accurate actually. That is called veracity means. The next thing is value, right? So earlier we used to define using these 4 V's: volume, velocity, variety, veracity. So the next thing came here before I define the value. For example, if you see high in volume of data, high in velocity, high in variety, high in veracity. If these 4 characteristics are qualifying, then simply you can call that one as a big data. High in velocity, high in variety, high in volume, high in veracity. If these 4 characteristics are qualifying, then simply we used to call that one as a big data. But do you think if you are seeing this one, but if there is no value out of your data, do you think that that is going to be any value for your company? Right? It's as simple as that. Right? For example, you are maintaining a IT infrastructure and you are retaining so and so data from long time, but you are not using the data at all. But because of that data, your system is training. Because of that one, your system is straining actually. So do you think that is a big data for you? No, because unnecessarily there is no value out of your data, but still you're retaining the data for no use actually. So there is a reason if you are retaining the bulk data, definitely that should give some value, should have some meaning out of that data to give some value towards your company actually. That is called value. Volume, velocity, variety, veracity, and value actually. That is all about the 5 V's. So very, very important thing. We took ample time to discuss on this one. So that's all about the big data definition using 5 V's actually. So what is Hadoop really and how the Hadoop is going to work? So we have to understand very clearly. So Hadoop is a framework basically, and it's open source one also, right? So framework is nothing but, so you as a developer, framework developer, you don't have to start your application from scratch actually. Hardly you have to develop only the 60 70%. Rest of the things will not be developed by the this thing actually. Hadoop is a framework. Also it is a open source one. So open source is nothing but free to use actually. You don't have to pay any license cost actually for that actually. So that is a open source framework. Excellent. And it was born to address both big data issues, storage issue and processing issue actually. So now what is the specialty with the Hadoop? Why your Hadoop is able to handle your big data in an effective way comparing with your legacy systems? So the one of the important thing that you have to understand here is, right, Hadoop is going to, Hadoop was born with very rich features friends. That is the reason Hadoop is able to really, right, address your big data related issues in an effective way actually. So Hadoop was born with the very rich features. One of them is going to the master slave architecture actually. Hadoop is going to follow the master slave architecture, which means Hadoop is going to work in a master slave architecture way. So which means master and slave. So indirectly, how the project manager and team member is going to work together within a team, the same way it's going to work. So this is the example always I give to all my participants, so that this example can be captured to understand most of the Hadoop concepts actually. So what is the project manager and team member? So very simple, very simple. Project manager is the one who is going to manage the team, right? Very clear. But why the team was born? What is the purpose of team? When you are working on your own, why you went with the team, right? That's what you have to understand very clearly. We went with the team because we went with the team because you are not able to really complete the work. You are not able to really satisfy your client on time for their work. That is the reason we went with the team actually. When your client is able to complete your work with you alone, then you are good. But the moment your client wanted to work to be done more from your end, but when you are not enough able to complete that, then you are going to say that, "Bus, I cannot complete." For example, if your client has assigned the work to complete in a day, but you are going to say that I'm going to take 15 days of time, then definitely, right? No way you can see your client is going to wait till that point of time. So for that reason only, definitely you have to understand team came into the picture, where team is going to work for you completely, where team is going to help you really to complete your task on time actually. So where you're going to see parallel, right, distribution, right? The distribution of the work is being done using the team actually. So which means instead of you alone working on top of your work, you're going to have the multiple people to work for your common task actually. So what is happen? So instead of you alone working, you are having 5 physical guys, 10 physical guys you are going to have, and you're going to complete that work actually, right? You have to understand that way. So when you go alone, when you work alone, you're going to take more time. But when you just work that same work with the 10 guys, definitely you're going to complete the work on time. You're going to take very, very less time to complete the work actually. So now that's how the team came into the picture. That's how you are going to just complete the work on time actually. So he's the project manager, right? And is going to be the team member one, team member two, team member three, something like that. You see, okay, that's how you are going to make sure these 10 team members are going to work for you to complete the work on time actually. Okay, so now let's see exactly this is called master slave architecture. Master slave architecture is nothing but master is the one who is going to manage the team members actually. But one thing that you have to understand here, how the team members are going to be managed. Project manager is the one who is going to take care of the team members. All team members has to report back to the project manager. If one guy is not working, your project manager knows how to handle that one, and how the other team members are going to be working as a backups for the other team members. All these things in a team is going to work actually. The same way Hadoop also is going to work for you actually. So here each and every circle you have to understand is a computer. It's a machine actually. It's a node. It's a computer. All are going to represent the same thing. So what is happened here? Instead of you alone working or only single server, single computer, single node is going to work for you, you're going to have a multiple computers you kept together within the network, right? You pulled multiple computers to work within the network together towards the common task, right? Instead of you alone working, you pulled 10 computers, indirectly 11 computers you pulled here, right? Including your master, you pulled the 11 computers together within the network where they can work together, where they can talk each other. So that is called cluster actually. So team is equivalent to the cluster, master computer, and it's going to be the slave computers actually, slave machines, physical machines friends. So how you are attending this meeting using your computer, so those kind of machines you are given 11 machines to build this cluster actually. So we are going to see down the line how we are going to build this cluster very clearly, we are going to see it. But 11 machines you kept together within the network to just build the right a cluster actually. So how they are going to help you out to really, we are going to see very clearly. In terms of storage, in terms of processing, how this Hadoop cluster is going to help you, we are going to see one by one. There is no limit to add the number of nodes to the cluster, number of machines to the cluster. If you want more storage capacity, simply go ahead and add. If you want more processing capacity, simply go ahead and add. So this is called horizontal scalability. You are scaling your system in a horizontal way, right? So that is one of the excellent feature out of the Hadoop. Hadoop is going to enable you to scale your system in a horizontal way. So for example, to really little bit elaborate that one, for example, you take the two organizations. One is Google, other one is for example, a small, probably your a banking sector. For example, if you are from India, let me give a simple example, any banking, ABC banking. So now you see your Google, whatever the infrastructure that is as, whatever the Google, you have the IT infrastructure, Google can manage, right? For example, forget about the Hadoop and all, existing infrastructure, whatever you have Google 15 years back, 20 years back, they can maintain, for example, 50 terabytes of data easily, right? Because the IT infrastructure that they have is really well matured one. They can maintain 50 terabytes of data in an easy way actually. But do you think the 50 terabytes of data can be managed easily by ABC organization from the banking sector? Because they did not think much about the data. They thought more about their business, not about the data. But Google has thought a lot of data is going to come because their business is that one. That's how they had the matured systems there. So that's how existing systems, whenever from the Google side, they see 50 terabytes of data is not a big data for them. But when you see the same 50 terabytes of data from ABC organization is going to be the lot of data actually. So your ABC organization can call that one as a big data, but your Google is not going to call that one as a big data actually. That is a difference when to call your data as a big data. Simply, whenever your existing systems are overloaded with the data that you see out of your organization, then you can simply call that data as a big data actually. So when extending horizontally, is it cost going to be increased as well? Yes. Instead of using one machine, you are as you are increasing horizontally, you're going to say 1 2 3 4, something like that. You are increasing horizontally, definitely you're going to put a lot of efforts to buy these things actually, right? Definitely, instead of buying one machine, if you're buying 10 machines, you have to spend 10 times actually. But you have to understand very clearly, Hadoop is going to claim that, right? They can use the commodity hardwares actually, cheap hardwares, general purpose hardwares actually. So when you go with the legacy side, for example, any MySQL server, right? So you cannot use the cheap hardwares there actually, general purpose hardware. Whatever you use in your personal computer, these are the general purpose hardwares actually. So you cannot use them cheap hardwares there actually. You have to use the high reliable hardwares, right? When you go with the high reliable enterprise hardwares actually, you have to end up spending a lot of money to buy those enterprise hardwares actually. So cheap hardwares are the general purpose hardwares and you have to spend very less amount to buy them. So Hadoop is going to claim that, yes boss, you can use the cheap hardwares for me to build actually, because I have my own tolerate mechanisms. Best features is best tolerate mechanisms that I have, where I can tolerate my data, where I can make sure my data is available more than one time. So that's how they came actually. Hadoop can use the commodity hardwares. One commodity, instead of buying one enterprise hardwares, you can buy 50, 60 commodity hardwares actually. There is a difference between the enterprise hardwares and commodity hardwares actually. So now how this is going to help you out to store your data. Let's go ahead and see one by one. So very simple. Hadoop is born to address your storage related issues and processing related issues. Let's go ahead and see how this is going to help you out. So very simple. So instead of one computer that you have, so right, in the legacy side, you have only one machine, right? You're going to maintain that complete thing using the single machine actually. And you're going to say standalone, individual machine. So now you see, for example, if you're having, right, 4 terabytes of data, you are going to see 4 terabytes of data will be managed by the single guy. So you are here, you are the client, and you're trying to use your legacy system. Then you are going to see 4 terabytes of data will be managed by the single guy. No way you can share it, right? You're going to just manage using the single guy. And when it's come to processing side also, right, you're going to see 4 terabytes of data will be managed by this guy actually. 4 terabytes of data will be managed by your single guy. In terms of processing also, single guy has to process actually. That is where it's taking more time, right? That is what the main issue with the legacy side. So now how this 4 terabytes of data will be handled by your Hadoop? Let's see that. So you are going to send the request to the team, and the team is going to, which means it's going to be notified to the project manager. So in the case, master computer is the one who is going to really notified, saying that yes, this is the work that I need to store. So now here in terms of storage, first initially we are going to see the storage, then after that I'm going to discuss about the processing side. So now you see 4 terabytes of data that we have. So for example, 4 terabytes of data that we have, I need to handle that one actually. So one thumb rule before that. So each and every machine hard drive, computer, you're going to have a hard drive. You know that your computer hard drive is how much, that much of data that you can store. So now I see 20 terabytes of data that you have, probably 32 terabytes of data that you have. 32 terabytes of data that we have each and every machine hard drive capacity. So 32 terabytes of hard drive is really huge actually. So to maintain the 4 terabytes of data, do you think 32 terabytes of data needed? So very simple. I can manage using this with the 4 terabytes of data I can manage, but that is the legacy way of managing your things actually. That is the legacy way of managing your these things. But how the Hadoop is going to do? So here one thumb rule that you can remember always, whenever you are going to store the data in the Hadoop cluster, Hadoop is going to divide the data into the chunks of data and distribute actually. He is not going to store your whole data together. Even though individual machine is enough capable to handle your whole data, your data will be divided and distributed actually. So what is the meaning of that actually? So now you see 4 terabytes of data. Let's say we divide into the 4 parts. For our easy understanding purpose, I just said 4 parts, but does not mean that it's going to be the 4 parts actually, right? We can go very in-depth discussion how the division is going to happen. We are going to see down the line. You don't have to worry about that. A simple, a layman way, right? You don't know anything about Hadoop. So you simply have to understand my 4 terabytes of data is divided into the 4 chunks and it started distributing this way.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to IntelliPad to know the right answer. Now, let's continue with the session.
Right, your master computer is the one who has distributed one chunk here, and one chunk probably here, and one more chunk somewhere else here actually, probably here. Let's just keep one more here. So that many rules, whatever you are going to assume, but you can break them actually. Right, friend, you can see very clearly here, instead of just going and depending on single guy, you are distributing your work to the multiple guys. You have divided your data into the 4 chunks and you distribute it into the multiple guys. So now you see one chunk here, one chunk here. You don't have to really distribute sequentially. If you are distributing 1, 2, 3, it does not mean that 4, 5 has to be used. That's the reason I broke that rule. I left the data slave node 3, right? Slave computer 3, I left it. And the next thing is, when you are accepting one chunk from one file, does not mean that another chunk cannot be accepted from that file actually. You can, as long as you are having the bandwidth, those many chunks also you can accept from your main thing actually. So that is how you can see very clearly how your data distribution has happened actually. Instead of storing using the single machine, we are going to have the multiple machines for you actually. That is all about the how the data division is happened and distributed. This concept only we'll be calling as a Hadoop distributed file system. So we can call them as a HDFS, Hadoop distributed file system, to address the storage by issue actually. So we are good with the storage things. And the next thing is processing side. So now definitely the processing is nothing but you as a user, you are going to send the logic, and also you're going to send your file name. That's all. This is my file name and I need to process this one. So this is the logic and this is the file name. So you as a user, you know this division, where your divisions, where these chunks have been distributed, which chunk is going to be really maintained by what and everything. Are you going to see this one really? The answer is definitely no, actually, right? So you as a user, you don't know anything. You don't have to know anything. All you have to understand, right, where the, I mean, what is my file name and what is the logic. So when I say logic, what you need to read out of that file, what you wanted to see out of your that file, actually, that is all about the logic, actually. So now that is how you send the master computer. Now master computer, so he is going to really check your chunks, whether it is accommodated by your slave 1, slave 2, slave 3, slave 4, something like that. So for example, if you take Yahoo, which is one of the biggest Hadoop cluster, right? 45,000 machines they added together. So do you think 45,000 machines that you have to scan to locate your data now? If that is the case, forget about the advantage that you see, but a lot of overload will happen, actually. But how you're going to see that? So one thing that you have to understand very clearly, so you are going to see at the time of storage, your project manager is going to maintain a log, right? Your project manager is going to maintain a log saying that, yes, my work has been distributed into this many guys, and these many guys are doing this one. And if anyone is requesting the work status, I need to go ahead and check with these guys. That's how he's going to maintain the log, right? Definitely. The same thing in Hadoop also, your master computer is going to maintain the a log. So we'll be calling that one as a metadata in our Hadoop terminology. That metadata is nothing but data about your data, information about your data. The real data is your your file that is being this guy, right? About this one, we are maintaining some information saying that my whole data has been divided into the 4 chunks. One chunk is there with the slave 1, other chunk is there with the slave 2, other chunk is there with the slave 4 and slave 5, 2 chunks. That's how that information will be maintained here, actually. The information will be maintained here. So this guy, right, the same thing, the moment your master computer is receiving any request to process, he's going to scan that metadata and is going to simply send the logic wherever the data exists, actually. So now, so here the request is being sent to this guy and this guy and this guy. That's all. So whichever the machines not involved, they don't have to work for this task, actually. Whoever is involved to accommodate your data, they have to work on top of your these things, actually. So now you see, so this is the data. Now you see slave computer 1, and this is the logic, and your master computer is going to assign the work to the slave to start working on top of this chunk alone. The same thing, the slave is going to work on top of this chunk alone. The same thing, this chunk is this slave is going to work on top of this chunk and also this chunk, actually. So that's how they start reporting the status back to the master computer, actually. So now master computer is the one who is going to consolidate the results and is going to report the status back to the client, actually. So what has done here, instead of just processing using the single guy, and as the data is being distributed the same way we started processing, actually. So we are going to see really in depth the concepts how the processing is going to happen, but at a high level, what has happened, where the data is being distributed, there only you started processing, actually. So this concept only we'll be calling as a map reduce. So map reduce is a programming model, right? It's a technique using which you can address the processing related issues, actually. Storage related issues will be addressed by your HDFS, and processing related issues will be addressed by your map reduce, actually. So now there are some ecosystems, right? These are core systems we can call core Hadoop core systems. If someone is asking what are the Hadoop core components means, these are core components. So you can get the ecosystems also, right? Ecosystems, but I'm going to define, we are going to learn pig. Pig is nothing but it's a scripting language, and it's an alternative to MapReduce, actually, right? So we are going to see how that is going to be useful and all. It's a Latin script that we are going to use, scripting language, and using that we are going to really just alternate it to the MapReduce, because MapReduce is a framework, right? It's a technique, right? It's a framework, it's a technique. So we have to use Java or Python to develop, actually. So Java or Python or Perl or Ruby also we can use it. To develop this, we have to use this case actually. But you have to understand very clearly. So MapReduce, right? It's a programming model using which you can process. But to develop that model, definitely you have to use Java kind of programming language. So now definitely you're going to ask me, do I need to know Java or Python to develop the MapReduce? Yes, right? We have to know definitely a Java, core Java, definitely you have to understand. Otherwise, there is no way you can develop the MapReduce. So that is the reason they develop the pig. So to avoid the writing your MapReduce using Java or Python, simply you write the pig scripts using Latin scripts. Very simple to understand, simple to really learn also. So you can just alternate the MapReduce. You don't have to know single Java if you know a little bit Python actually. The same thing Hive. Hive is same as SQL. So the engineers who are from SQL background, Facebook thought like they should able to really come up and develop the Hive Hadoop application. So that's how they develop the Hive framework. Hive is same as SQL. If you know the SQL, then you know most of the Hive concepts actually. So these queries again, they are going to just use to alternate your MapReduce actually. You don't have to worry. So you know pig, you know Hive actually. We are going to see HBase also. HBase is nothing but NoSQL one. What I mean by NoSQL, not only SQL databases, there are different NoSQL databases are available. So using that, you can maintain. NoSQL specialty is nothing but you can maintain the billions of instructions in your table. So when it comes to big data world, using row oriented, right? Rows and columns, it is not easy to maintain that much of data. That is the reason, right? We go with the column oriented actually. NoSQL databases are the one of the column oriented database. We are going to see in depth about that, but you can maintain entire data using the single column. How and all we are going to discuss in depth in the HBase discussion. You don't have to worry about that. Okay. Then the next tool that we are going to discuss about the Scoop actually. So to import the data from RDB MS DBs to Hadoop world, we are going to use Scoop actually. SQL to Hadoop actually. Scoop is nothing but SQL to Hadoop. So really to import the data from RDBMS DBs to Hadoop, we are going to use Scoop actually. So Scoop, the same thing, Flume, right? Flume to import the streaming data from large log files into Hadoop side, we are going to use, right, Flume. So they both are data ingestion tools. To get the data from outside world into the Hadoop world, we are going to use these two things, Scoop and Flume, but they have their own different usage. We are going to really discuss down the line how we can use them in a different way. But a simple one line statement, Scoop can use to get the data from RDBMS world, and Flume can be used to get the data from the streaming, definitely from large log files into the Hadoop actually. The last thing that we are going to discuss, Oozie. So Oozie is a scheduler actually. So to run your jobs in a particular pattern, right? If you take any organization, it's not something only one job that you're going to run. You have to run multiple jobs to really maintain your data actually. So for that, we use Oozie actually. Okay, so these are all about the ecosystems. We are going to discuss in depth about them as we proceed further. So now let's go ahead and discuss about the HDFS now. So HDFS, now we know very high level about the Hadoop cluster. It's a combination of multiple machines, and we are going to have master and slaves. Master is the one who is going to maintain the slaves, and slaves are the one who is going to report back to the master. We know very well. So this is going to be the master computer, and this is going to be the slave computer. Let me take this picture, just have in one more pen so that I can make use of that one for the. Okay, so let's proceed further. So how we are going to make use of this? So this is what your master computer, master node, computer, both are same. Slave node, slave computer, both are same. Slave node, right? And also we can call this one as a worker node. And also we can call this one as a data node. All are going to represent the same thing. Slave node, worker node, data node, all are going to represent the same thing. The only slave node one, you can call them as a data node one or worker node one. Anything is fine. Okay. So now let's go ahead and see. So how this is going to be helpful? So one thing that you have to understand here, master is the one who is going to manage all these things. The same concept that we discussed here, but how we are going to manage the data. For example, you have a file, right? File name is called temp.txt file. So who is having, right? So and so size. So then how you are going to manage the data, we are going to discuss one by one. So this is the this is the temp.txt file. Then I wanted to store the data into the Hadoop cluster. So from here onwards, every topic is interlinked. So please try to concentrate on my screen 100%. If you're not able to follow any time, any screen, please do stop me. Okay, so now next thing, temp.txt is the file that I wanted to store the data into the Hadoop cluster. So now, like I said, the file has to be divided into the chunks actually. So now how that is going to be divided, who is going to decide that one? So all these things we have to discuss one by one. So now here, as we know, this division, right, in our Hadoop cluster, the division is going to happen at the file level, not at the cluster level, not at the directory level also. As you know, every directory is going to have a multiple files. If you take a Windows, as you use most of the time, you use in a Windows folder, you see the multiple files. Each file is going to just have in the directory. So, but the division is going to be at the file level, right? And this division, a user can decide how they wanted to divide the data actually. How they can decide and divide the data, they can decide here actually. But for example, user has not decided to divide the data into the chunks. Then there should be the default division also has to be there, right? Based on the Hadoop version, we can just go ahead and divide the data into the chunks of data. For example, you see temp.txt file, and don't worry about the chunk, but let's go ahead and see. I'm using the Hadoop one version. So there is one version and also there is two version also. And nowadays we are using three version also, but very rare, it's not matured. But two and three, there is no difference. Two and three, very in-depth concept. There are differences, but you don't have to worry about that. So Hadoop one version, initial version. So what is the default division actually? So based on the size, right, we have to divide, right? So whether you go with your own division, whether you go with the Hadoop version, but you have to have a concept. You have to have a parameter to divide the data into the chunks of data. That parameter name only is called block size actually. So block size is nothing but the way you are going to divide your whole file into the chunks of file.
Just a quick info, guys. If you want to learn data engineering, then IntelliPad provides a job guarantee program in collaboration with MIT MicroMasters. This course will be taught by MIT professors and industry experts. This course will help you to upskill and land your dream job. Now, let's continue with the session.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to IntelliPad to know the right answer. Now, let's continue with the session.
So what is the block size here? So let me define the block size here. So default block sizes that we are going to see, but what is the block size means? Block size is a parameter. Block size, what is that block size? It is a parameter, it is a argument, or it is a just a simple value using which parameter, using which we are going to divide the whole file into chunks of file. So you can read. I'm requesting everyone to read this one so that you will understand what is the block size. So I know as we proceed further, it will confuse you, but you have to understand block size is a parameter using which we are going to divide, right? Block size is a parameter which is used to divide your file into the chunks of file actually. So this block size, you as a user, you can define whether the based on the version you can go, A default block size is based on the version that you are going to have. For example, you decided to go based on the version, right? So when you say Hadoop version that you're using one, then all in every machine you're going to see only one. It's not something one in one machine, two in other machine. You're not going to mix it. So for example, you as a Hadoop user, you decided to go with the Hadoop one version. So what is the block size that you're going to see as a default way? It's going to be the 64 MB actually. 64 MB is the block size, default block size using which you are going to divide the data into the chunks of data. So 128 MB in two version actually. So what does this mean? This means your whole file has to be divided into 64 MB is the block size so that you start seeing the number of blocks, chunks, sizes, slices, pieces, and all that we used to call as a layman way. But now you have to understand that is a blocks actually. The whole file will be divided into the number of blocks, right? So temp.txt file is being divided into the block size actually. So now, for example, so what is our really right file size? For example, temp.txt file is having 100 MB and the block size that I'm going to have is 64 MB because of the one version. So how many blocks? So two blocks, right? B1 64 MB and B2 36 MB, friends. So that's how that division is going to happen. So any questions? So the block size can be configurable. Going forward, when I say configurable, you can go all the way with the 1 MB minimum block size that you can go with 1 MB, which means you can go and configure your block size there 1 MB in one version and two version. Maximum block size can be anything. I should give as a star here, right? Block size can be anything, but one thing that you have to understand, so we should not go more than 256 MB as per our recommendations, because the more block size that you have, the more resources and availability that you are going to see actually. So that is the reason you have to understand very clearly block size maximum 256 MB that you have seen so far in my work experience actually. So minimum that you can have 1 MB, the maximum can be 256 MB. Indirectly you can take that one as a selection. 1 terabyte. Let's do how we are going to do 1 terabyte. If you are going to convert into the MBs, so you can do 1024 or 1000 also, does not matter. So this is what 1 GB, right? 1024 GB equal to 1 terabyte. Again, if you do multiply with 1024, it became what? MBs actually. So now it is 1024 into 1024 equal to 1 terabyte by 64 MB. Both are MBs, right? So if you do this guy, what is that answer? That is going to be your answer. So it's going to be the 16,000 something, right? 16,556 something. You see that correct answer. But 15,000 also it's fine. 16,384, right? I think that is the, so now file one 70, right? Then both are MBs. I don't have to convert. There is no work for me. Then 64. Then how many blocks ended up having? B1 64 MB and B2. The rest of the data we just track as a B2. What is that? 6 MB, right? Then file 2. So what is that? Your 10 MB. So by 64, there is no way you can divide, then you are going to track that one as a B1 actually. So now how many blocks you ended up having? First one is 2, second one is 1. So total 3 blocks actually. That is the answer actually. So this is the calculation. So one thing that we are clear now, how we can divide our file into the smaller files and track them in our HDFS file system. Very, very high level we are able to discuss. Let me take you a little bit in depth so that you will understand more on this one also. So now you see, right? So this is how your master computer and who is there for you to manage your data. So now, for example, temp.txt file. So now it has divided into the smaller files, which is block 1 and block 2, as 64 MB is the block size, B1 here and B2 here. Or for example, B2 somewhere here where you are having around, right, data node 1, data node 2, data node 3, data node 4, and data node 4000 or 5,000, for example, right? These many machines are there in your cluster. That's how the data distribution is happening, right? So one thing that you have to understand, right? These are master component, master node. So now you are the one who has stored the data, and that is how it's settled, which is good. So now, for example, another client, another user came into the picture and he wanted to read your temp.txt file. You send the request to the temp.txt file. Out of your temp.txt file, now you send the request. All you are going to say that, yes, I would like to locate the temp.txt file. So the request will go to the master node. Now, master node is going to scan 1, 2, 3, 4, 5, something like that, 5,000 files to locate your temp.txt file, which is just 100 MB of file. No way it's going to happen, because each one is, for example, 32 terabytes or 64 terabytes of data that you have, right? So then definitely what will happen? It is going to take a lot of time to scan just 100 MB of file. So forget about the advantage that you see, but a lot of disadvantage that you can expect out of this connection. So for that reason only, what your master computer is going to do, he's going to maintain the metadata here, friends. So metadata is nothing but, right, data about the data. So information about the data. That is the metadata definition in our Lehman language. So information is what? Simply some data that you are maintaining about your real data. The real data is temp.txt file. About that we are maintaining some information. So here our Hadoop is going to maintain some information about your each and every file. So that is called transaction log, you can call, or metadata, saying file name, file size, block size, right? Number of blocks, blocks location, right? And user group, and for example, date, and permissions, right? All these things that you can expect as a metadata is going to have. For example, our temp.txt file, let's see, the file name is temp.txt file, and file size having 100 MB. Block size that we wanted to have is a 64 MB. Number of blocks is 2, and blocks location B1 is there with the data node 1, and B2 is there with the data node 5000. Okay, and user, for example, XYZ, user belongs to super group, and date 08 something 24 or whatever it is, and permissions, read, write, blah blah blah, whatever it is, right? So this is how for every file these guys are going to maintain this information, and it's going to be the flat file, right? So your metadata will be managed by one of the master computer in terms of flat files, actually, right? Binary format, nowhere you can read it, but it is in terms of binary format. Now you see this whole file has been tracked this way. Now you see, right? So this file is a flat file, binary format, nowhere you can read it. But the moment your master computer is going to receive any request, he has to scan this file. If there is any entry in this file for this file, then only it's going to say that the file exists. Otherwise, it's not going to. It's going to say that file does not exist, actually. So this is a temp.txt file. If it is exist, it's going to say yes, it is available. Otherwise, it's going to say that not available, actually. So temp.txt file, and it is available, and it's going to check B1 is there, the data node 1, and B2 is the data node 5000. Simply is going to send the request to B1 and B5000. He does not have to scan the rest of the machines because they are not involved in accommodating this data, actually. So that is all about the metadata. So you see, can you locate your file without metadata file? Right? Is it possible to locate your metadata file? I mean, without your metadata, is it possible to locate your actual data in the HDFS file system? The answer is yes. It is not possible. It is impossible. So that is the reason metadata is a hot kind of thing for your HDFS file system. If there is no metadata, no way you can locate it, actually, right? So if you are missing the metadata, no way you can locate this guy, actually. That is the reason we call this one as a say counter piece of your HDFS file. It's a hot kind of thing. So if you are missing the metadata, nowhere you can recreate this one. You have to start from scratch. You cannot do the reverse engineering saying that data node 1 is having these many blocks from these many files, then I'm going to recreate this metadata. Nowhere you can create, because you don't have user information, you don't have permission information, you don't have date, you don't have groups information. All these things you cannot rebuild again from the existing file system. You have to retain the metadata as much as a backup, as much as you can, actually. So that is the reason metadata is going to play very, very important role actually. So who is going to maintain the metadata? One of the master computer. Yes, if the master computer is going down, that is what Veera's question. What will happen? Your complete cluster will become the inaccessible actually. So is a Lehman way we are calling as a master. I'm going to introduce the real names for that now. A high level, you're just calling as a master nodes, but at a low level, we are going to see. So who is managing the metadata? One of the master computer. That master computer name, let me introduce. That is called name node. Name node is a master node. We'll be having the multiple master nodes in the Hadoop cluster, right? Name node is a master node. ABC is a master node. XYZ is a master node. We are going to introduce one by one as we proceed further. Okay, so name node, I just introduced the one master node, the first master node, that is a name node actually. So you have to understand name node is a master node who is going to really take care of your Hadoop metadata, Hadoop cluster metadata. As of now, it's going to have a multiple responsibilities. One of the first responsibility I'm introducing the name node actually, metadata. So name node is the one who is managing the metadata. Name node is the one who is managing the all external clients in terms of writing the data into the Hadoop cluster, in terms of reading the data out of your Hadoop cluster. Again, I'm repeating, in terms of whenever you're writing the data into the Hadoop cluster, whenever you're reading the data out of your Hadoop cluster, you are going to see, right? Name node is the point of contact. The metadata also will be managed by the name node actually. And also whenever you are assigning the work to the data nodes, you are going to send the work, the name node is the one who is going to send the work to the data nodes in terms of data storage. So I just introduced one master computer, that is a name node actually. Okay, let's proceed further. So these are the data nodes or worker nodes. You can call them with any name that you wish. So this is going to be the name node. Let's start with our real names, name node actually. So now name node is the one who is managing the metadata. You know what is metadata, and is the one who is going to manage the worker nodes, data nodes, right? Worker node, data node, slave nodes, all are going to represent the same thing, friend. Okay, so whatever number of machines. So now m.txt file that you just send to store the data, and block size that you wanted to have is 64 MB. Then you ended up having two blocks, B1 here and B2 is somewhere else. So now as we can see, every participant is expecting, yes, if you are just missing the metadata, then you have to start from scratch. For example, it's been 2 years you started, or it's you're interacting with your Hadoop cluster, and you missed your metadata file, so you are going to start from again scratch, right? For example, 1.5 year back you started, and from 1.5 year onwards, whatever the activities that you have done, you have to redo again. So is it going to be acceptable? Definitely no, right? So you cannot redo the same thing again. It's really not easy actually. Okay, so now let's see, we have to have a backup for this one. Is there any way to recover the metadata file? Excellent, right? Definitely everyone is expecting metadata backup actually. But next, before we proceed further, you have to understand, right? So anytime in this cluster setup, right, anytime if someone is sending any request, that request is being sent to the name node. Name node should be always active. At the same time, you should listen that request actually. The same thing, you're sending the request to the data node, right? Data node also should be always active and should be responsive back to the name node. So for example, though you're in online, if you're not responding me back, what is the purpose of staying in online? No, actually. So that is the reason always every machine has to have a listener kind of thing to take care of their responsibilities actually. If you remember, if you know a little bit about the daemons concept. So what is daemon here? Any language. For example, if you know a little bit Unix, you know the daemon. If you know a little bit MySQL, you know the daemon. If you know a little bit about server side, you know the daemon. Daemon is nothing but it is a process, right? It's a process or program that will be running always in the background actually. So that is all about the daemon. Daemon is the process or is a program that will be always running in the background actually. So now here, if you go with the MySQL side, MySQL D is the daemon that has to be always running in the background in order to just to take care of your MySQL responsibility. The moment you are not running that, your MySQL is not going to be the accepting any request from the outside clients actually. The same thing here, each and every machine has to be responsible to take care of these actions actually. For that reason only, we go ahead and just make sure some of the daemons we are going to run in our Hadoop cluster. Hadoop daemons. So total we have 5 Hadoop daemons that we have actually. So let's go ahead and name it one by one actually. So name node is a daemon, right? I'm going to run one listener, right? Always in this machine, that script, that service, a program, a script, a service, right? We are going to run in this machine that is called name node actually. So now first daemon I introduced, name node daemon. So now here also, right? In every machine, we need to run one daemon to take care of the data node activities. So that is called data node daemon actually. In every machine, it's not something one data node is going to, one service is going to take care of all machines. If you're having 50,000 data nodes, means 50,000 data node daemons you are going to see. Each one is going to run one, in every machine you're going to run one data node daemon, and that is going to take care of that data node work in terms of storage, in terms of reading the data out of your Hadoop cluster, in terms of writing the data to the Hadoop cluster actually, right? That is name node and data node. Name node is going to take care of your all responsibility what we discussed, and data node is going to take care of that one. And again, at the same time, you see those responsibilities actually. Clear? Name node, data node. So what else? So now you see, as we are expecting the backup for your metadata, we are going to have one more master computer to take care of the metadata backup. So that is only the purpose, friends. Please try to understand the purpose of this computer. Then after that, I'm going to introduce the name, because name also is going to confuse you, right? Because they gave very bad name, the worst name than your blocks is they gave this name. So it may confuse you. So I don't want to confuse you. That is the reason I am requesting you to understand this mission purpose. Then only I can introduce the name. So now you see, every 1 hour, what this machine is going to do is going to copy the metadata from this machine into this guy. Every 1 hour, you are copying your metadata every 1 hour from this machine to this machine, and this can be configurable. You can go with less time, you can go with more time. So for example, this machine is gone, right? You are not able to recover your hard drive also out of this machine. Then I can only just locate this machine to recover this metadata, friends. That's all. The moment your name node is going down, I'm not going to bypass this request to this machine actually. I'm not going to take care of my data nodes using this machine. It is not going to do this one for you. What is the one time of 1 hour, which means after every 1 hour, from now, after next 1 hour, you're going to take one more file backup from this machine into this machine actually. This is one more master computer. We are just backing up that one into the other machine. This is one computer, this is one computer. That computer name only, right? Secondary name node actually. So this is secondary name node, which is just taking care of your metadata backup. So we are going to run one more daemon that is called secondary name node. Right. So far we have seen name node, secondary name node, data. 3 daemons that we have seen. So 2 master computers, name node and secondary name node, 2 master computers that we introduced. Okay. So now, so far we are discussing about the storage, name node, data node, secondary name node, all are just handling your storage. How about the processing side? So when I say processing, right, your data has been settled. Now one client came and you wanted to locate your data. Probably he came up with the MapReduce and you wanted to process against that. So now MapReduce request will be taken, it will not be taken care by the name node actually. So MapReduce request has to be taken care by the one more master computer. That guy name is called job tracker. So in Hadoop one version we'll be calling as a job tracker. They are the one who is going to take care of your all MapReduce jobs. And in 2, we are going to have the resource manager actually. Okay, so we are going to see what is the resource manager in Hadoop 2 version. So job tracker and resource manager. So job tracker in one version, and that has been replaced with the resource manager. What does that mean and all we are going to see. Yarn architecture actually. Definitely, I'm going to take you there. Actually, you don't have to worry. In depth, I'm going to take you there actually. Right. So we are going to run job tracker. Right. So job tracker is the one who is going to take care of all your jobs. So now the request is been sent to the job tracker, and job tracker has received the logic and is going to receive the file name. That's all. Temp.txt file is the file name and this is the logic. That's all. So job tracker has any information about your blocks of your file. So this file name is temp.txt file. Then that's all. Where the blocks exist, where they are available, all these things, who knows that? He has any intelligence to locate the data? He has any capable to locate your data? No, exactly. He does not have that information. So who has that information? Who knows your block report? Who is enough capable to handle your block report? Metadata. But who is maintaining the metadata? Exactly, name node. Then simply I need to request the name node. Definitely, but I need to know this is the my file name, but I would like to know what is the block report. So now name job tracker is the one who is going to send the request to the name node. Name node is the one who is going to scan the metadata, right? Who is going to scan the metadata and is going to check how many blocks are there and where they exist, and they are going to simply report back to the job tracker saying that yes, stem.txt file has been divided into the two blocks, and it is there. Block one is there, the data node 1, and block 2 is there with the data node 3. So now that's all. Job tracker is the one who is going to be start interacting with the respective nodes where the data exists actually. Okay. So now job tracker is at the cluster level, friends. All is managing the jobs. He cannot go all the way with the data node level and cannot just really do anything actually. So he's going to just have one more housekeeping the here. That guy name is called task tracker actually. So task tracker is the one who has to take care of these things actually. So job tracker is this guy. Task tracker is the one who is going to take care of the job tracker works. So indirectly, job tracker is the one who is going to assign the work to the task tracker, saying that yes, this is the logic, and you have a B1 from the temp.txt file with you. You go ahead and start processing this guy. Now task tracker is the one who is going to start the process against this block one with this logic. Then from here onward is going to report the status back to the job tracker. The same thing here it has happened, right? So from here onwards is going to send the status back to here. So job tracker is the one who is going to track the complete status and is going to take the help from again one of the task tracker to consolidate your results. We are going to see in depth about the job tracker at the time of map reduce discussion, but end of the day job tracker is the one who is going to consolidate the end results and is going to report back to the client actually. So that's how, right? Task tracker also is been introduced actually. So what is that? Task tracker in one version, right? That is being replaced by the node manager in Hadoop 2 version. So we are going to discuss more about this job tracker and task tracker, or resource manager and node manager in our coming discussion actually. So any question? These are the 5 daemons that we are going to run in our Hadoop cluster. So let me take the questions one by one. So all you have to understand this, each and every box is an individual computer. A typical Hadoop cluster is going to have a this way. These are all individual machines, individual computers. It's not something you're going to merge together as a single machine actually. Right? So Arti says, where is the job tracker is running? In the other machine, other computer. Name node is one computer, secondary name node is one computer, job tracker is one computer actually. Right? What is the task tracker? Task tracker is at the data node level to take care of the all tasks actually. Right? Data node is the daemon that is going to take care of all in terms of storage, in terms of reading and writing the data. Task tracker is the one who is going to take care of the all the jobs in terms of writing the data, in terms of reading the data out of your Hadoop cluster action. Okay, so now you see data node 5 and also this one, and this is how your data will be sent, temp.txt file, and so you see B1 is here and B2 is somewhere else here, right friend? So now please concentrate on my screen. So now this is how your data has been settled. So now these machines are the commodity hardwares, right friend? Cheap hardwares, general purpose hardwares. They may go down any given period of time. So definitely you have to have a backup for this guy actually. So now the moment they are going down, then you are not going to realize to have the backup friend. There's no way you can just do that one, right? Definitely you have to have a backup before, right? Even though it is going down now, should have a backup. So for that one, what a Hadoop cluster is going to do, for example, your data node 1 went down, so your B1 is not available, then only B2 is available. That does not mean that only one block is not available. What is there, friend? I will go ahead and process B2 to see my output. No way you can see that one. Definitely 100% the data recovery has to happen before you start processing your data actually. Without, right, no way you can really process the data. Out of your 1 TB of file also, if one file is missing, one block is missing out of your 16,384 blocks, one block is missing, nowhere you can process that file actually. It's going to say that block is missing, right? Somehow the data recovery has to happen. So now you see that node 1 went down. Now B2 is only available. Then you have to recover now to process your temp.txt file. If that is the case, definitely you see a lot of really disadvantage here actually. So for that reason only, what my Hadoop is going to say, at the time of copying the file, I can maintain the multiple copies actually. So B1, B1, B1. So 3 copies by default I am going to maintain, B2, B2 and B2. So now for example, I'm going to distribute this one into the randomly based on the bandwidth that is available. So B1 was here and one more B1 was here and one more B1 was somewhere else here actually. So now B2 is here and B2 is somewhere else here actually. So now you are not maintaining exactly data node replicas, but the copies that you are maintaining for your data. Indirectly, one file, block one is indirectly one file, and you are maintaining that in the 3 places actually. So this is called a replication factor actually. The default replication factor in 1 version and 2 version and 3 version, everywhere it's 3. Default RF is 3. The minimum, again, this can be configurable at the file level, not at the cluster level, not at the direct level. It's at this purely at file level. How we add the blocks at the file level, the same thing. The replication also can have the block level, file level. The minimum replication factor that you can have is 1, and the maximum replication factor that you can have is anything. So when I say here anything, really anything, right? Really anything that you want, you can have. The more replication factor, the more data availability here actually. So now let's see. So you see here at the time of copying your data, you maintain 3 copies. So now indirectly, instead of maintaining 100 MB, you are maintaining 300 MB of data in your Hadoop cluster. Hey Shiva, you are already having the lot of data. On top of that, you are having 3 times of data. Yes, I of course I can do that one. How many machines that you want, I can horizontally add to my cluster, right? Commodity hardware, cheap hardware. There is no need to worry about the storage. All I need to just take care of my data with the very limited amount. So now you see B1, B1 and B1, right here. So one B1 is not available, right? This complete information will be maintained in the metadata front. It's not something only one copy will be maintained and the rest of the copies will not be maintained in the metadata. No. So everything will be maintained in the metadata. Other thing that you have to understand, there is no priority that I'm assigning, right? First one is B1, first priority. Then second one is B2, second priority. Third, data node 4 is having third priority. There is no such concept actually. All are having the equal priority. So for example, the moment your name node is receiving the request to locate your temp.txt file, it has to locate only one copy, right? Not 3 copies, only one copy. So now B1, it was not available in the, it was available in the data node 1, but it is not available now. Then no way you can locate out of data node 1. Then what else we have? Data node 2 and data node 4. So dead node 2 and dead node 4 B1 is available. Then out of these 2 machines, which one is having the more bandwidth? That machine that you have to locate. For example, dead node 4 is having more bandwidth. When I say bandwidth, I'm going to really discuss more about the bandwidth actually, right? So how the bandwidth distribution is going to happen now, right? How we are going to locate that one, we are going to see down the line. So you see dead node 4, I'm going to really locate B1 because dead node 4 is having more bandwidth. When I say more bandwidth, we are going to discuss down the line. What do you mean by bandwidth and all? That is purely based on the RAM and hard drive. So that is each machine bandwidth is going to come out of that one only, right? So now out of B2, now B2 you see dead node 2, dead node 3, dead node 4 also. So now out of these 3 things, I'm not going to prioritize anything. I'm going to see the equal priority out of these 3 copies. which one is having the more bandwidth that will be picked. For example, dead node 3 is having the more bandwidth. So now dead node 3 is going to be picked for the B2. So B1 from dead node 4, B2 from dead node 3 actually. So that is how the replication factor is going to help you out. So replication factor, it's a fault tolerance mechanism using which you increase your data availability in the Hadoop cluster. Instead of just depending on a single copy, you made sure 3 copies are available for you so that you can just maintain the data, right? Or you can process your data without waiting to recover your data from there actually. At what time the data replication happen? When the writing the data or after some time? At the time of writing the data. When you are writing the data into the Hadoop cluster based on the replication factor, your data will be replicated. So then the second thing is how your right data node is going to, how your name node is going to know that your data node 1 went down, right? You have to have that mechanism also. How your name node is going to know your data node went down, right? So that is also you should understand. Each and every data node is going to send the signal pulse back to the name node saying that I am alive. So that will be calling as a pulse, heartbeat, or signal. Every data node has to send the signal back to the name node saying that yes, I am alive. So that is going to be the every 3 seconds. So this can be configurable by default 3 seconds. Every data node is going to report back to the indirectly ping back to the name node saying that I am alive. For example, let's see the first data node 1 case actually. So name node did not receive any signal from the data node 1 first attempt. Then it's going to see the second attempt. Then it's going to see the third attempt. Then you see, yes, your data node 1 went down, your name node did not receive even after third attempt. Then is going to, your name node is going to confirm saying that data node 1 is dead guy. So he's no more active in the networks. No way I can assign any work to this guy actually, right? Going forward, I cannot assign any work to this guy to accommodate my data. At the same time, I should start recovering the data that was there in the data node 1. You are not going to report the data node 1 to recover the data. Your data is what data is available, what data is available in the data node 1, you know already. Who you as a name node, you know that one. With the help of metadata, you know that. So now your data node 1 is not going to just accommodate only B1 and is just waiting ideally, right? So for example, this is having 16 terabytes of hard drive means 16 terabytes of blocks you are going to accommodate, right? 16 terabytes of files you are going to accommodate. So thousands of files has to be, thousands of blocks has to be recovered immediately because your data node 1 is not responsive actually. So I'm just giving the example for the B1 from the temp.txt file. The same thing has to be followed for the other files, right? Now you see B1 is available here. So now you see B1 temp.txt file is available in the data node 2 and also data node 4. Your name node knows that one because this metadata is available in this guy. So now B1 has to be recovered either from the data node 2 or data node 4. So at this point of time also, name node is going to check who is having the more bandwidth actually, right? Who is having the more bandwidth, that guy will be picked actually. So in this case, our data node, right? For example, dead node 4 is having more bandwidth. Now is going to assign the work to the dead node 4 saying that, yes, data node 4, I see block 1 from the temp.txt file. You have to just copy that one into the dead node 5. So now B1 from the data node 4, now you are going to copy to the data node 5 as a B1. So now data node 4 has copied the B1 into the data node 5 and you recover the data immediately. You see after 9 seconds, automatically he is able to heal himself actually. You don't have to manually do this process. Automatically this will be taken care by the Hadoop cluster actually. So this is one of the excellent fault tolerance mechanism that we have in our Hadoop cluster. So every name node, data node, how you are sending the heartbeat back to the name node, how your name node is managing the metadata at the cluster level, your data nodes also is going to maintain the metadata at the data node level. So this is called data node metadata. You know the data node metadata is nothing but only the data node metadata, which means what files from what blocks are there from what files, how they are doing, right? whether the data is real data was there when it was copied, the same data is there, or it is corrupted. All these things will be available in this metadata. This metadata will be just shared back to the name node actually. So along with your heartbeat, your data node metadata also will be shared back to the name node. So we'll call that one as a block report, BR. Every data node is going to share the metadata from the data node to the name node in terms of block report along with the heartbeat actually. Based on this one only, your main name node metadata will be shuffled accordingly, because earlier data node 1 was having one of the copy from your temp.txt file. Now is it available? It is available with the data node 5. So the moment your data node 5 is sending the block report back to the name node saying that yes, temp.txt file one of the copy is available with him, then your name node has to has to update the metadata to the current one, so that in future request, if someone is locating the temp.txt file, you should be able to give the correct exact location of your blocks actually. So that is called all about the block report. With the block report, you are able to make sure your name node metadata is shuffled up to date actually. Everything is clear. Now your data has been settled. You are maintaining the 3 copies. So now your admin came into the picture and he has looked into this one, and there was a network issue and he has fixed, right? He is ready to rock and roll, which means he is ready to take care of your work. There was a network issue and is fixed. So when you say fixed, he is not going to recover the data that was there here. temp.txt file b1 2000 from your log file, 25,000 from your so and so file. There is no way you can see, you can recover that blocks actually. Simply he is going to really format this file data node, right? He's going to delete the complete data that was there here, and is going to act as a fresh machine, and is going to accept the new work from the name node. He's not going to even restore the status back here actually. If that is the case, you are going to see a lot of work only for this game. Your data is been recovered and recovered, that's all. So why you have to go again and recover this data, right? Why you have to retain your old status of your b1? Your data has been recovered, that's done, right? So that is all about the how, if one of the machine whichever went down, how you are going to get it back, how your recovery is going to happen. I hope you are clear. Even for a tricky question, you should be in a position to answer, right friends? So let's proceed further. So these are called, right, multi-node cluster, right? Multiple machines. It is ideal in the production environment. For example, your production is having 20,000 machines. So do you think I need to maintain the 20,000 nodes in my development environment also? Do you think I need to maintain the 20,000 machines in my test environment also? Right? Really not possible. Nowhere you can maintain these many machines in the every environment. So that is the reason you can really develop with any number of machines, and you can deploy that code to any number of machines, and you can run that application with any number of machines. So that is the reason multi-node cluster is ideal only for the production, but in the development environment we are going to use single node cluster, right? Single node cluster is nothing but your all daemons you are going to run in a single machine actually. So name node, secondary name node, data node, job tracker, task tracker, all these daemons you are going to run in a single machine. But what is the purpose of this one? Are you going to get any performance here? The answer is no, you don't get the performance. But what you get? You get the concept wise how it is working, you are going to get. But the performance wise, you have to get out of the multi-node cluster actually. So multi-node cluster only can give the performance, but the single node cluster is going to just give you the for the development purpose, that's all. So that is all about the multi-node cluster.
Just a quick info, guys. If you want to learn data engineering, then IntelliPad provides a job guarantee program in collaboration with MIT MicroMasters. This course will be taught by MIT professors and industry experts. This course will help you to upskill and land your dream job. Now, let's continue with the session.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. the Apache PyTorch? Comment your answer in the comment section below. Subscribe to IntelliPad to know the right answer. Now, let's continue with the session.
What you have to do in Oracle VM VirtualBox is click on to the Oracle VM VirtualBox. This is the main link. Okay, and here are the sublinks for different operating systems. I have I have also given this particular link as well, so look into that. So based on the operating system that you are using, okay, based on the operating systems that you are using, try to click on to any one of those links and a file will get downloaded in your system. Okay, let's say I'm using a Windows operating system. I'll click on to this and there will be a file that will be downloaded. Okay, so after downloading VirtualBox, you just have to double click on that so that to install that particular application. Okay, a double click on that particular application and it will ask you for certain yes or no. So you have to click on next, next, next and continue. Okay, can we use to Hadoop VM setup for Linux? So as per as the downloads with the respect to the virtual machine, VirtualBox, just click on next, next and continue. Do not try to change any of the default settings. Okay, let there be all the default settings as it is. There is no requirement for you to change the default settings. Just click on next, next, next and continue. Okay, and so after installing VirtualBox, please make sure that you have installed it properly. How to check is just go to your search window and just type in Oracle VM VirtualBox. Okay, just by typing initial words, you should be able to see an application that is present in your system. You should see that. Can you see this? This is my downloaded file. This particular is the file. What file? This file. Okay, after we have downloaded successfully, the file should be looking like something like this. Okay, before, okay, if your VirtualBox is not installed, this will be of an unsupported format. So as I have already installed VirtualBox in my system, this will show you some of a supported format. And how can you check whether this is of a supported format? Just double click on it. It will redirect your page to the VirtualBox directly. Okay, it will redirect to that particular application, which is nothing but your Oracle VM VirtualBox. Okay, now you can see the specifications. So basic requirement is, as let's say, as if you have a 8 GB RAM, so we are specifying 4 GB of RAM to my virtual machine. And you also can change also, when you check onto this, you can change the RAM size also, but preferably, because you have to have a decent amount of RAM allocated to your virtual machine, we keep all the settings as default. Okay, so let's say if you have a 16 GB, no worries, 4 GB is totally fine for the virtual machine. Just click on to import. As you click onto that, it will require a total of 10 minutes for you to completely import all the things that your downloaded file has. Okay, so as I have already started this will not be showing to you. This is a different virtual, this is the virtual machine which I have already. Okay, when you are starting for the first time, this also will not be there. Okay, I will cancel this because I already have imported everything in this particular thing. Okay, so after importing, after a time span of nearly 7 to 8 minutes, the entire downloaded file will be imported as Ubuntu. Let's start the virtual machine. We have already imported the virtual machine. Let's start just by clicking to start. Please notice that as this is a local on-premise virtual machine, it will take some of the time. Okay, because it has to start a new virtual machine inside your local machine. You have to have some patience before it gets initiated. Start this, you will get this particular window. Okay, it is asking for a validation whether you are for Hadoop. So you have to always select on Hadoop. This is where all your Hadoop frameworks have been installed. Just click on enter. You should be initiating your Ubuntu virtual machine. Yes, finally we have got into our virtual machine. So this is the entire installation process. We also had a file with respect to the commands as well. These are my command files. When you open this, you will see many different commands. Okay, why exactly these are commands? What are these different commands? You will have a basic idea on top of that itself. So start dfs.sh is used to start the Hadoop cluster. So start -yarn is used to start yarn services. So, and also JPS command is used to check the status of all the Hadoop services that is currently being running in the system. Okay, and also there is something with respect to the name node from web browser, how you can access the name node, resource manager, all this thing. I will show you how exactly you have to do. And also there is something called as different framework that are available, and according to each command, let's say if you want to start a Hive shell, these are nothing but the basic and the most used commands that is very much important for you to use them in the future, in the upcoming course. So many commands are there. What I ask you is, whenever you are running all the commands, please make sure that you are familiar with the commands usage. Okay, whenever you are executing this particular command, you should know that actual use case of this, which is nothing but to start the Hadoop cluster. Whenever you're using start yarn, you should know that it is starting the yarn service. Similar to that, this again, we are using this pig command to get into the pig shell. Yeah, Hive command to get into the Hive shell, Spark command to get into Spark shell. Okay, so now if you ask me where exactly do we execute these commands, let me show you that. So there is a terminal in the virtual machine. Okay, just click on to that. You should be able to access a terminal. So this is your terminal. So where exactly you have to run all the commands? You have to run all the commands in the terminal itself. Let's say your first command is nothing but to start the Hadoop cluster. Get into the terminal, just type in start-dfs.sh, which is the command to start the Hadoop cluster. Click on enter. It will start all the requirement that is necessity with respect to the command. So it will start your name node, data node, secondary name node. Till when you have to wait to get the complete process done is until you get back the same terminal, which is the Hadoop at IntelliPad-Hadoop. Please do not try to execute any other command. It is starting secondary name node as well. Yeah, so not yet we have got that, so we have to wait until it gets back to Hadoop at IntelliPad-Hadoop. So as you can see that we have got back the same Hadoop at IntelliPad-Hadoop. Let's run a few more commands. Let's use this particular command. Let me show that. Start-yarn.sh.
Just a quick info, guys. Test your knowledge of big data by answering this question. Which of the following are incorrect big data technology? A. Apache Hadoop. B. Apache Spark. C. Apache Kafka. D. Apache PyTorch. Comment your answer in the comment section below. Subscribe to IntelliPad to know the right answer.